Last meeting, we started to cover the energy equation. Energy equation. This equation or this topic is very important if you are planning to pass the FE exam. If you have a pipe and you have flow in this pipe, so if we select this cross section, section number 1, and this cross section, section number 2, just a hint, if you are talking about continuity equation, I can say area of this section 1, V, velocity of flow 1, and we have here area 2, V2 must equal. And both of them equal the discharge value. This is based on the continuity equation. Based on the energy equation, I will say at this location we have pressure. At this location we have velocity. At this location we have elevation. So I will say P1 divide gamma plus Z1 plus V1 square divide 2G at this cross section must equal the same parameters at the other cross section, equal B2 divide gamma Z2 V2 square divide 2G, but for the real situation, we expect losses between this cross section and this cross section. So we have to add here H losses. H losses equal two main parts, H minor and H friction. This one can be called minor losses, and this one is friction losses. Does that make sense? We covered last meeting what is the meaning of friction losses. According to Darcy equation, friction losses equal F, friction factor, L, the length of the pipe line, divide D, diameter, V square, divide 2G. And we learned last meeting how we can figure out the value of friction factor based on the value of roughness divide D. I can use the given chart to figure out the value of F. L is the length of the pipeline, D is the diameter, V is the velocity, G is the acceleration of gravity. Today, I will cover the second part of losses, which is minor losses. Minor losses equal C times V square divide 2G. More simple. Minor losses, if we have two connections like this, we have flow, and this flow suddenly enter another part of the pipeline, or we have this tank and we have flow through this pipe. So at this entrance, we have losses, and these losses can be called minor losses. Based on what is the shape of this entrance, do you have sharp exit or sharp entrance or rounded entrance or something like this? Based on this situation, I can figure out the value of this constant. The value of this constant. So if you have sharp exit, C equal 1, if you have sharp entrance, C equal 0.5. If you have round entrance, C equal 0.1. If you have different keys, we will be given in the problem. So minor losses equal C V square divide 2G. Let's do this example. We have a discharge Q equal 1 cubic feet per second. We need to calculate the total head loss. Please be careful. We are looking for total head loss. That means we have H minor and we have H friction, because we are looking for the total losses. In 1,500 feet of new 6-inch diameter cast iron pipe. So we have many information here. The length of this pipeline, 1,500 feet. Diameter of this pipeline, 6-inch, which is 1/2 feet. The material of this pipe is new cast iron pipe. And given the fitting have characteristic value, C is given equal 0.8. What do you think? I think H minor equal C V square divide 2G. Like this expression. And H minor, H friction equal F L divide D V square divide 2G. Looks like if you would like to get the minor losses and the friction losses, you have to figure out what is the velocity. Any idea? How can you tell me what is the velocity? Any idea? Guys, do you have any idea how can I figure out the velocity? Thank you. Thank you. We have something is given here we didn't use. Discharge equal area V. Discharge is given 1. Area, I can figure out what is the area because I know what is the diameter. So pi divide 4 times this diameter square. This is the area. Time V, I believe this equation can give you what is the velocity is. Let's try. So pi divide 4 times 0.5 square. This velocity will be 5.1 feet per second. That makes sense? Excuse me. So the minor losses equal C, which is 0.8 times V square, which is 5.1 square, divide 2G 32.2. I can figure out the value of the minor losses. Equal 0.32 feet. What about the friction losses? Okay. How can I figure out the F? The value of F. So what is the value of roughness divide D? I need to open this chart. We have cast iron new pipe. So the value of roughness is 0.00085. and the diameter value is 1/2, so the value will be 0.0017. Okay, let's use it. 0.0017, 0.001, 0.002. So I believe 0.0017 something here. 0.0017. If you go to the other side, we can figure out the value of F, 0.02, 0.03. So I think this one will be 0.0225, probably. 0.0225. So the F value will be 0.0225. So I can put F 0.0225, the length 1500, the diameter 1/2, velocity 5.1 square divided 2g. I can figure out the value of F friction. This value is 27.3 feet. Do you have any notes? Did you notice anything? The minor losses equal 0.32, the friction losses 27.3, so the total losses 0.32 plus 27.3, so your answer will be 27.62. Anybody has any comment? You should tell me something. You should tell me something. Yeah. I know the total losses equal H minor plus H friction. The minor losses is very, 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 very small compared to the friction losses. This value is 0.32 feet. This one is 27.3 feet. That means the meaning of minor losses, something can be neglected. It's very small if you would like to neglect it. The main losses is coming from friction. That makes sense? It's coming from friction. We have to experiment. The first one, if you have channel and you would like to measure the velocity. For some reason, you are walking in the street and you have a channel or canal and you have water flowing in this canal and you would like to measure what is the velocity. Because if you can measure the velocity and you can measure the area of the cross section, I can figure out the discharge. We have a little bit experiment here. We have something called Betty tube. Betty tube looks like a tube with right angle shape. L shape looks like this. This Betty tube will be inserted to the water, the direction of flow like this. So we will make this side or this leg of the tube parallel to the direction of flow. So the water can go inside this tube and rise up. If you can measure the distance of the water inside the tube above the water level of the canal, which is H, this height of water equal V square divided 2G. So the H is measured. G is the acceleration of gravity. I can figure out the velocity. That makes sense? So open-ended tube with 90-degree bend near one end. When the tube is placed in a flow stream with the open end directed upstream, water will rise in the tube to a height above the surface equal H equal V squared divided 2G. From this relationship, I can figure out if the height can be measured, then the velocity can be calculated. Once the velocity is calculated, the discharge can be calculated. It's very simple. If you have this tube, you can measure the velocity. Example, the height of water in a petty tube is measured to be 7.3. H equals 7.3 centimeter. So we have water, we have flow in this side or in this direction. So I put the petty tube like this, and the water rise in the petty tube with height H equal 7.3 centimeter. Can you tell me what is the velocity of this flow? Okay, this height equal V square divide 2G. So 7.3 equal V square divide 2 times 9.81. Please be careful. And I told you this information before. If you are talking about SI unit, which is meter, centimeter, kilonewton, G equal 9.81 meter per second square. If you are talking about US unit, which is feet, inch, pound, G equal 32.2 feet per second square. So be careful, because the height is given here in centimeter. So we are talking about SI unit. So the value of G will be 9.81 meter per second. We have a big issue here because this value is meter per second and this height is still in centimeter. So what should I do? I need to convert one to the other one. So I will convert 7.3 centimeter to be in meter. I will divide it by 100 equal V square divide 2G. The only unknown in this equation is the velocity. Your velocity will be 1.2 meter per second. Any question? Guys, do you have any question? If you have any question, let me know. So what we covered today, we covered how to calculate the minor losses. We covered how to measure the velocity in a canal using a petty tube. We have another technique can be used to measure the discharge. The discharge, which is called Venturi meters. This device can be connected to the pipe at this location, for example, and this Venturi meter can help you to figure out what is the discharge in this pipe. The Venturi meter consists of a carefully designed construction. You are doing constriction in the pipe that causes flow velocity to increase in accordance with the continuity equation. Anyway, so we have two cross section, section number 1, section number 2. Here is the Venturi meter at section number 2. The discharge will equal CA2, the area at section number 2, square root 2G P1 divide gamma minus P2 divide gamma divide 1 minus G2 divide D1. Make sure D1 and D2, the cross-section area at section number 1 and section number 2. P1 and P2, the pressure at section number 1 and pressure at section number 2. Using this equation will help you to figure out the discharge directly by Venturi meter. Venturi meter will help you to measure the pressure at section number 1 and section number 2, and the diameter is known, so I can figure out the value. We have a constant here, C. C is a coefficient between 0 and 1 and will be given in the problem based on the used device. The last example here, we have a Venturi meter is installed in 6-inch pipe. The regular pipe has a diameter D1 equal 6 inch. Because you installed Venturi meter, we did contraction, in the pipe with diameter D2 equal 2.5 inch. We have a piezometer reading from the pipe center line are as follows: gamma 1 divide G at this location, gamma 1 divide G equal, I'm sorry, wait. It's not gamma 1, it's P1 and P2. P1, not gamma 1. P1 divide G at this location equal 0.95. P2 at the Venturi meter divide G equal 0.52. What is the discharge in the pipe if C equal 0.95? Okay. Discharge equal C area at section number 2 square root of 2G P1 divide gamma G, I'm sorry, minus P2 divide G divide 1 minus D divide D, D2 divide D1 square, I think, or to power 4. As I told you, you don't need to remember all of this equation because the exam is open note. Okay, put your numbers. C is given 0.95. Area at section number 2 is by divide 4 times 2.5 inch. I will divide it by 12 to be in feet square. Here is the area. Square root of 2G, G is 32.2. P1 divide G is given 0.95 minus B2 divide G is given 0.52. Divide 1 minus D2, which is 2.5 inch, divide D1, which is 6 inch. I can keep them as in inch to power 4. Because if you convert this one by dividing by 12 and this one by 12, you looks like the same. So you can get the final value, which is cubic feet per second, which is the discharge in this pipe. Very direct problem, but you need to remember, the only information you need to remember all the time, we have something called Beat tube. This Beat tube is a device, can be used to measure the velocity in a channel or in a flow. How can I use it? You need only to put this L-shaped tube opposite to the direction of the water. So the water can go through the pipe and rise up. Then you can measure this height. This height equal V squared divided 2G. Then you can figure out what is the velocity. We have another device called Venturi Meter. This Venturi Meter is installed to any pipe, will make contraction, and using this expression will help you to figure out what is the discharge in this pipe by measuring few parameters like pressure, like what is the area here and there, and what is the contraction factor, which called C, and it will be given based on the type of Venturi meter you are using.